I'm also going to fix the Etherpad link in the agenda.
Ah, yes. I don't know if we did that for the TEEP one. We talked about that yesterday. I don't know if Nancy fixed it.
No, I think yeah, it's like I'm just thinking when I wake up right now. How do I get out of this? Should I say I constantly?
I'm trying to find the second person.
That would be
Yes, the link is there. Okay, we got a jabber. We got a jabber already.
You didn't update this type of slide.
What's that? I did.
No, this one claims it's Monday. It's Tuesday.
No.
Should I open it? No.
Oh,
You updated the
yeah,
agenda saying the main page.
I didn't.
I didn't even notice that until.
My bad.
Do you
But
want
you want
to
me to-
stay since I'll be presenting?
all right, good morning, everyone. You are in the TEEP or Trusted Execution Environment Provisioning Group. If you are not expecting to listen to the TEEP, you might want to move to a different room. Okay, so this is now Tuesday. How many are new to TEEP and to the IETF? To the IETF. Okay, so if you haven't attended any sessions, we follow some sets of procedures with respect to how we conduct the meeting and IPR, which is noted here in the note well, which I'm not going to read, but I encourage at least the new participants to go through that. We have, from an administrative standpoint, I was able to commandeer, and so I want to thank Stephen, who's back there, who will be our Jabber scribe, and Dave Waltemeyer and Rich Saltz, who will be our note takers. And I did fix the Etherpad link, which should be the same link, and I copied all of the notes from Monday on that. So, so just feel free. You'll see a lot of text. Rich and Dave, you can just start from the bottom. Thank you. Okay, so with those logistics out of the way, I just wanted to recap and note that we had a full session on Monday. We didn't have time to have Dave present on the transport protocol. So for today, we've updated the agenda to allow Dave to do the presentation on the updates that he's made to the transport protocol. Hannes is going to provide a discussion, if you will, and a proposal for how we can continue to further evolve the OTRP protocol. And then Soren is going to discuss one of the issues that's been on the GitHub. So if there's time left there, if not, I want to use the rest of the time, at least in the second part, for us to discuss a way forward for the OTRP protocol itself and the drafts. So it's kind of loose in the agenda for the chair to lead that discussion. At around 11 o'clock, because we needed some of the key participants from the RATS group, Dave Thaler is going to lead the discussion on the alignment there. And so that will take about 20 minutes, but we can't start until Hank, literally, and other RATS participants. RATS. Hey, I am the RATS chair as well. So we resemble that remark, and we're proud of the name. I'm too close? Okay. Sorry. Is this better? Okay. Usually they're telling me, eat the microphone. Okay. And then we'll have David also talk about issue number 17, which has some relation potentially to the RATS as it discusses the attestation work. So I prefer to lead the discussion, but we might start on the OTRP moving forward. Lead that discussion in the beginning, depending on the time. So with that, any other comments on the agenda? Moving once, twice? Okay. So Dave, do you, did you find?
Yeah, all of them are up somewhere. Not necessarily in the correct order.
Okay,
Okay.
I got it.
For this discussion, I am not chair. I am acting as a document author, and Nancy is the chair, and our backup chair is our AD over there. Okay. So I am just an individual participant for purposes of this discussion, everything I say. All right. So this is talking about the transport spec, and in particular the OTRP over HTTP transport, right? In the future, we could potentially have an OTRP over COAP or something else transport, but this is the OTRP over HTTP update. Okay. This is now a working group document as of last IETF. We adopted it. Oh, can you go into like full screen mode or something, the little expand thing? So there we go. Yes. Okay. So as I said, this was adopted as a working group document last IETF. The document was moved over into the working group GitHub, and the GitHub issues have been used for issue tracking. There were 3 issues filed. They were raised outside of GitHub, so I filed them by copying them into GitHub. And that's the ones that I'm going to talk about today. Number 3, I claim, is done, but I'm going to talk about all 3 of them. And the other 2 are not necessarily completely done. We will see. All right. So I'm going to start from the easiest one. Okay. This is the one that I claim is already done. Okay. Where previously, the transport spec was the one that said, when you're going over HTTP, right, the headers have a content type, right? What's the content type for OTRP? So previously, that was in the transport spec because the OTRP protocol spec had not been revved in quite a while. And so temporarily it was in there. That's now moved. Both documents that Hannes will talk about before now have an INA consideration section that covers media type stuff. And so that information has been removed from the transport spec. It was just a placeholder in the first place. And so now all normative content and INA considerations are not in here. However, informative content is in there. So when it goes through examples of what your HTTP headers look like, you'll see a content type in there is purely informative. Okay. And so this gets to the point of the benefit of this is that when we define other media types, such as what if we use CBOR, which as the instead of JSON, right, then the media type is different. And so we just pick one of those as the example and leave all the rest up to the protocol spec, right? because the transport doesn't actually care. It takes the content type and it hands it up to OTRP. So that one I claim is done. And so that issue is closed. Okay. The terminology alignment, Ming talked about this a little bit yesterday, and so now I'm going to drill down into this particular issue. Okay. And so the labels on the boxes on the right are the labels as they appear in the current document, or at least this diagram doesn't appear in there, but the labels for the roles that appear. So you can see at the top, you have the OTRP protocol that talks between a TEEP agent and a TAM. Below that, you have the transport, the OTRP over HTTP, as specified in this document, and it talks between what's currently called the TEEP broker and a thing for which is currently labeled TAM broker. And Ming mentioned this yesterday, and part of the question is what's the right term there, and I'll talk about that. And then below that, since this is over HTTP, you have an HTTP client and an HTTP server. And of course, below that, you have other protocols like TCP or QUIC. And so you have a TCP or QUIC client and server, or if you call it an initiator or listener, whatever. Okay. So this is kind of your protocol stack, right? Okay. The architecture document, as it exists right now, has the green terms, right? The TEEP agent, TAM, and TEEP broker are terms that appear in the architecture document itself. The other ones don't appear in the architecture document. So part of the question that Ming asked is broker, and that I had asked before that too, right? So both of us are asking, is broker the right term for the OTRP over HTTP layer? Okay. Well, in the architecture doc sense, when we, the working group, talked about broker before, we defined the term broker as being the piece that was outside the trusted execution environment, and therefore it was in the rich execution environment that was talking to the trusted execution environment. So you have some agent inside and a broker outside, okay? And so that was a division between the trusted world and the untrusted world inside the device, okay? Now here you see a protocol stack. And so you said, what's the relationship between the protocol stack and the dividing line between the trusted and untrusted world? In the reference architecture we've been using, the dividing line is in between OTRP and the OTRP over HTTP layer. So in between the top layer and the second layer, right? That was where we had it in the reference one, at least on the TEEP agent side. On the TAM side, we've said the whole thing could be in the rich execution environment, or there could be a dividing line between TAM and the TAM broker, right? Where the top is in the TEE inside of a TAM, and the bottom from TAM broker on down is not, okay? That's also a valid implementation of a TAM. Well, if you look at the left side, okay, it would also be a correct implementation of a protocol interoperable on the wire if you move the boundary downward. What happens if you put, say, your TLS implementation, so everything from HTTP client on up? Could you put all of that inside of your TEE and have the dividing line to the RE down be at the sockets layer? So TCP is in the regular sockets layer, and everything from TLS, HTTP, all the way up is inside the TEE. Could you do an implementation like that and be compliant to the protocols? Yes, you could. Okay. And so in that sense, what is the broker, right? If you call the broker the thing in the REE, now you have a socket broker. It's a TCP broker, right? It's not the TEEP broker as it's labeled up here. Right. So what I'm wondering is maybe broker isn't the right term because broker is a term for a different axis. It's the term for the axis of REE versus TEE, not the term for the axis of protocol layer. Okay. If you believe that, then broker is not the right term for either of those two boxes. Okay. It's a different axis, right? Secure and insecure versus protocol layer, right? Now in the reference implementation, we put the boundary at the top, such that your TEE code can be as small as possible, right? The farther you go down, the more code you bring inside the TEE, and it gets bigger. And usually for security, you don't want lots of extra code inside your TEE, right? So the reference architecture is still correct as being as high as possible, meaning right below the TEEP TAM agent. But the other implementations are fine too, okay? So in the terminology alignment, right now, after thinking through this, I'm thinking that TEEP broker and TAM broker is not the term that we should use in the transport spec. It is still a term we should use in the architecture spec for talking about the piece that is outside the TEE, right? So that's my personal proposal, but none of the documents match that right now, and I'm interested in what the working group thinks now that I've explained that issue to you. I see nods and head scratching. Does anybody actually have an opinion on this, or should the document editors just do something? Ah, an editor of a document. Coming to the mic. Thank you.
Dave Wheeler. I guess the thing that I'm then trying to understand is in the architecture spec, if we continue to use TEEP broker, then that terminology would flow to different elements on the protocol stack, as I understand what you're saying, right?
Yes, in the reference implementation, meaning the way that we use as the primary example, right? The broker would be at this layer, right? The one currently called TEEP broker and down. But a different implementation could have a broker that's way down here, right? And so it would be different ways to implement your broker if we do that.
Right, and then that becomes confusing because then the functionality and responsibility of that entity changes depending upon your implementation.
We've already got the same confusion over here on the TAM side because there's two ways to do the TAM, right? The REE is so everything down, or the IE is everything down?
Let me pose a different question to you then.
Okay.
If we remove the name broker, then what is that second row of boxes in the protocol? What is its responsibility in the protocol stack? So
you're saying,
I guess what I would propose is saying that if broker isn't the right name, but there is still a protocol layer, the second one down, let's be clear about what its responsibility is, regardless of whether it's in the TEE or outside the TEE, and then name it appropriately for that. But what I didn't get from your discussion was what do you think the responsibility of that protocol layer is?
So I can imagine two options, right? One option is to keep this broker, okay, and to say that, yep, you could implement it in other ways, but we're going to specify it this way. Okay? That would be a valid option. That's more consistent with what the documents do right now, is to say the dividing line is right here between TEEP agent and TEEP broker, TE up, REE down. And on the right side, it could be, anywhere. So we could do that. And then the responsibility is twofold, okay, which is to proxy between the two worlds and to do the task that's going to be I'll describe in a second. So the other approach is to say they're two orthogonal axes, right? And the responsibility is to abstract the OTRP protocol from which transport it is, right? So this is the plugin for OTRP over HTTP, okay, as opposed to OTRP over CoAP or whatever, okay? And in another issue as I come to, there might be two different versions of HTTP or not, right? So we'll come to that. And so the role in either case, right, or the second role in the first case and the only role in the other case is to say I'm trying to abstract. So the OTRP protocol is specified without any knowledge of whether it's HTTP, without any knowledge of whether it's CoAP. It's just a protocol. You have to have something else. So just the analogy would be IP does not specify what the link layer is. You need a IP over foo layer that actually does that. That's the analogy here. This is the OTRP over foo layer that does the mapping between the generic, upper layer thing and the generic lower layer thing, just like we do for any IP over foo layer, 6LoWPAN, IP over Ethernet, all those things fit into that same category in my analogy. So I'm okay either way. If we choose to say the reference design is just how we're going to spec it and we use the term broker, that's okay too. But that's why the issue is still open, because I want feedback from the working group. The editors have had a little bit of a discussion, and now everybody that's had this discussion is standing at the mic, and so we can now have this not just as a design team, but as a working group discussion. So please, I'm interested in opinions.
I think what TEEP broker, at least for now, is represent a common typical case, right? We talk about the extreme case, different possible implementations where TEEP broker doesn't look that aligned. As it's for the architecture, it's written there is really the common case, typical case, i.e. was a TE interface where you cannot have direct access. So one option is whether we can mention TEEP broker if the HTTP client is able to be handled inside TE, whether we can make TEEP broker maybe optional, right? Because for some implementation, maybe it's not required. But I think the architecture represents the typical case. For the TAM side, we mentioned that entire stack, TAM or the network stack, can be in the RE rich OS side. I'm not, I don't have strong opinion there. I just felt initially we have TAM, right? That's what happened in architecture document today. TAM as service, it's leave the implementation to the TAM provider, how they architect that stack. Because on the cover, HTTP, the transport, TCP, so on, they may choose different ways. Because now we kind of dictate more granularity there. We have this network responder, right? Time broker that try to reprint that. And we isolate time to be the message responder engine, right? That will have that first row. And so whether we can live with that way, that is the architecture document. For protocol, to a transport protocol, I understand that once it's a little dilemma there. Transport, but we may want to mention that TEEP broker at client side, and you have network responder, particularly for HTTP, right? Because the transport protocol, we talk about HTTP. There may be future other transport protocol that they may have different word there. Doesn't have to be same in architecture document. I think they have different document may have a variation here.
Just to check the clock, Dave, you still have 2 more issues you want to talk about? Okay, because we got like 5 or 6 minutes
Thank you.
left.
Yeah, I was going to
During
say.
the queue. Yeah.
This is honest. I agree with Ming. I think that's a common implementation case today, so it makes sense to use that as a baseline assumption. We should add the other sort of discussion points or possible implementation cases, as you mentioned, Dave, into the document, because I think it's important. You do, however, raise a very interesting point, namely, if you, for example, move the DLS implementation into the secure world, then you could, in theory, get rid of many of the other sort of security mechanisms that we built on top of it. You can actually make it then simpler, and that may be something that we should think about and at least make a decision, because like, as we will see later, you still have then what we did at the application layer. We created this Cypher suite.
I'm cutting the queue at Dave Wheeler, by the way. Okay. Because
I know.
you're
I
out
want to move
of,
on.
yeah, you need to move on.
Dave Wheeler. So short comment. So my perspective based on your discussion is that what we've been talking about in the specs is really an implementation and splitting the layers here based upon what functionally was working in the prototype. What I think you're getting at is we really should be having a protocol layer. So the top layer is the OTRP TEEP application protocol. The next layer is really a presentation protocol. Is it JSON, OTRP, ASN1, Dave's formatting, and then your next layer is your transport, whether that's HTTP or something else, right? But really that second layer is not OTRP over HTTP. It's the encapsulation of TEEP into a format language. Now,
that part is not true. Hannes is going to talk about that in his presentation.
yeah.
So I want to punt that issue until a future discussion item where we have more time.
But I'm not sure that, so I don't agree with a protocol layer of OTRP over HTTP. I think we need more discussion of what is that real protocol layer there. If we're going to go to a straight protocol stack diagram and name the layers.
This issue is purely about terminology and the alignment between the architecture document and that one. You're having an architecture discussion, file an architecture document issue, talk about it, or talk about it in the protocol. All right, I want to move on to an issue about HTTP bindings that was filed by Anders, and it has not had discussion much on the list, and so I took that as saying people probably don't understand it, and so I am going to say what he actually talked about in words here, and I don't know if there's discussion or there may not be time for discussion, but I want to point this out. Okay, so the current model looks like the one on the left, right, where you have a device that has your TEEP agent in it. That's the one that's being provisioned with code and personalization data or whatever. And you have a TAM that might be in, say, a cloud service or at least some other server that it can talk to. And in between those, you might have a firewall or a NAT. And so because of that, that means the connection has to go outbound from the device. And so you see the red arrow is the direction that HTTP goes. And in response, the OTRP channel goes reverse across that. That's how it's currently specified, okay? Because that's the primary scenario, okay? Anders is saying, well, I have or I think that there's a case for, the rightmost model. And in his example, he says, what I'm trying to do is I'm trying to provision a TEE that's off in the cloud someplace, okay? And I'm trying to provision it from an application manager that might be an app on my phone, okay? And so in this case, the app on the phone might be behind a firewall, and so the only way to talk between these two is to reach out from the TAM to the TEEP agent. And so you can see here the OTRP and HTTP lines go in the same direction. And so he says, don't you need a binding for this case here? That's what he filed his issue on, okay? Now, even going back to our BOF and the poster that we had, the discussion there, at least this is my rephrasing, hopefully I got this approximately right, that OTRP is most applicable when the entity wanting the TA installed, such as a user, is different from the entity authorizing the TA installs, right? Because OTRP communicates between these two parties, the one that requests the TA and the one that authorizes the TA, okay? And so if those entities are not different, you don't need a protocol between them if they're merged into the same thing, right? And so the question is, does this case happen in a cloud case, right, where the entity that wants it installed is different from the entity that authorizes it? And so you can ask, is the guy using this device, is this phone, is it actually have both entities? If it is, then maybe OTRP isn't the right protocol there, or is it, right? Maybe it is, maybe it isn't, okay? That's what he's really asking, okay? And so for the transport spec, right, I'm just at the behest of what OTRP working group wants to do here. And so for the transport spec, I could maybe do nothing, in which case we're saying out of scope, never going to solve, okay? Option B was to say, well, we're not going to solve it right now, but maybe someday if there's interest in the working group, we want to come back to that. And so maybe we should at least change the title to say that this isn't all possible HTTP bindings. It's OTRP over HTTP for this use case or something like that. C is, we could say, oh yeah, everybody else jumps up at the mic and says, I love Anders' use case. We have to solve this now. And so we could do that. And we could do that in a separate document or in the same document. Okay. I think the default answer I would lean to as an author might be B. Are there any objections to my recommendation of going forward with B?
You got to make it quick because he's almost 10 minutes over. So
I just I was a good guy. For me, it's this second case kind of out of scope.
It's kind of, that would be A. Okay, you're arguing for A. Okay.
I'm not good to address a case where currently running my laptop, I manage data center machines which run TE.
I asked a colleague of mine that deals with TEs in the cloud, and they said, not right now, but maybe someday, who knows? That's a paraphrase. Okay. All right. That was my last slide.
Okay. I think we're going to move on because we're running out of time.
Yep.
Okay. So, Hannes, I think you're next.
Okay.
2 or 3 times. Oops. Do I have to click again?
Yeah. Sure. Can you do something about this?
3 clicks.
Okay. Did I? Okay. I'm on the front. Oh man. Okay. Good. So we've made a number of decisions in past meetings, and so I thought it would be a good time to not only update the architecture document, but then also reflect some of those decisions back into the protocol specification so they don't get terribly out of sync. And here's some of the decisions that we made over the last few months or a year. We decided to remove the support for the security domains and maybe deal with them as an extension. We said that we would be using Suite for the software description, software updates, and align with that work, with the manifest work. As we discussed later, we also said that we want to leverage the attestation work from RATS and also have a CWAR-based serialization in addition to the what we already had with the JSON-based work. And along with that decision also comes the security wrapper, COSI and HOSE in that case. We also added the support for multiple DEs, not just one DE, which we had initially in the specification. So a lot of changes, like at the architecture level, conceptual and decisions we made. And so as I was trying to reflect those into the protocol document, I realized that there was actually a lot of redundant text, which had to be stripped out, and sometimes not just redundant, but actually conflicting statements. And so things that we decided, for example, to remove the trusted firmware text, it was still in there, and so on. So lots of other changes. And in all fairness, we tried to cover a wider set of use cases, so I think that's perfectly fine. And we changed the terminology. We talked about it previously. So as I was trying to make these changes, I realized that, oh, I'm stripping out so many things and I'm rearranging so much stuff, and which led essentially to a new document ultimately, which is why you saw this new document. We weren't quite sure because it's a bigger change from what we had previously to what this document is about. And so it was submitted as an individual document rather than a working group document, because some of you may have otherwise gotten quite surprised. And one issue that came up is, how do we actually deal with backwards compatibility? Because initially that was one thing that when we started the work, as you know, with all the history of global platform and the work we were doing that together on OTRP, I tried to see how I could have all these changes implemented but still maintain backwards compatibility, minus the whole changing even the encoding, which of course is kind of difficult to maintain backwards compatibility. And so I wasn't able to do that. I couldn't see how I would maintain backwards compatibility with all the changes I listed on the previous slide. And so essentially the question to the group for me was, like, how important is it for us to actually have that backwards compatibility before I go further in talking about how this version actually looks like? And if we say it's okay to break backwards compatibility and have a sort of a new version, there are obviously different ways to deal with this, and there was a brief discussion on the mailing list. I call this version 2. Jeremy suggested that maybe it should have a different name. Maybe there are other ways to deal with this, but I'm trying to see where you guys are heading on that. So do you think it's okay to break backwards compatibility and have something that is slightly different to what came into the group, just because of normally we wouldn't care, like initially contributions to the IETF are a starting point, and often at the end what comes out doesn't need to be compatible with what we started with. In this specific case is slightly different because of the background with global platform.
Yeah, let me just comment that agrees kind of here. So this one is we do not have version 1.0 in IETF, right? For RFC, there's no version 1.0. So the question is really about, do we need to maintain backward compatible with global platform version? It's really across industry standard bodies, right? If you treat global platform that way. So it's not within that, right? We do not have one official document. We're not talking about the backward compatibility for existing implementation. Some people have followed the prior RFC draft, right? We're not dealing with this.
Yeah. Okay, that's a good point. So in some sense, there is no version 1.0 because the global platform work is also not finished. So in that sense, yeah, good point.
Dave Taylor from the participant mic. When I tried to implement this at past hackathons, when I tried to implement the what you might call the V1.0 at hackathon, I entered a bunch of issues in the issue tracker that I presented in previous working groups. In other words, I don't think the previous document was interoperable with itself. You could have an implementation of it that interoperates with another implementation of it, but you had to have more information than what was in the spec. So what that means is, what I believe is that there is no V1 specification in either body that is actually interoperable. So if you talk about backwards compatibility, you might say, I want backwards compatibility with a particular implementation of the spec. That would be a valid claim, but I would like backwards compatibility with the spec. I don't think that statement can exist from my experience as an implementer.
Okay. So point of clarification, in the global platform, the OTRP specification document is not complete.
So let me, I can comment that I can come to this question, right? So global platform called it TE Management Framework, TMF, TE Management Framework, Open Transport, OTRP profile. So really adopted OTRP draft and made it a called profile for TE Management Framework. It published in last December, okay, December 2018. It kind of for some of official, I would say. It's not, and then half firm, it's accepted, but there was a lot of work. This kind of call for comments. It's currently in a website public available. You can download. So I would say started that way. Related, interoperability. Well, Dave's comment. I say within global platform, we try to do that, but for us, right, it's across different boundaries. That particularly is put under TE global platform TE management framework.
But they still call it Open Trust Protocol. So I think if we publish something having the same name for something that is then different because they modified the incoming sort of version as well.
I feel like inclined to do the two name change with terminology. The first one, compatibility with global platform not possible. You have completely adopted these different things.
So I think there's actually two questions, and that was the discussion that I was going to lead at the end. So, but we can do it here, and then we might defer.
Okay.
Just to give you, so I don't know if you have more slides.
Of course I have more, but not on this topic.
But this this will be I think a much longer discussion. Just trying to stay respectful of the time.
Yeah. But it's kind of important.
Which is why I'm saying we need. But I do think there's two different vectors that we need to discuss. So to me, the name change is a different question than breaking compatibility. And the reason why I'm trying to ask clarity, on the global platform OTRP spec is there may not be a breaking compatibility issue if that has not completed. That meaning the global platform specification.
Yeah, I would say, well, they publish it, and we need to track that. That's the way do they make it the official standard that their group members will implement that as a standard, because that's a different way we're doing the track, right? We're doing that to control.
Okay, sorry, I'm trying to. It's not clear to me. So, to the global platform, are they considering a version of a document as their standard?
I consider so, yeah. For them, it's selected as a home final, and OTP profile for TMF, right? T manual framework. For them, it's kind of final to work it down.
But irrespectively of whether, so I can double check, but whether they finalized the work already or whether there's still something ongoing as a sort of next, I don't know how that processes exactly work, but what is in this document that I'm describing here, it is not backwards compatible with what they have, regardless on how it looks like.
Okay, so I think, Hannes, we should ask the two questions. One is, moving forward here in TEEP, does the group want to break compatibility with the current version of whatever's documented in global platform? So that's question number one. Question number two is, should we change the name of what we're adopting to something else? That
sounds good.
Okay. So if you guys have further comments, make them quick, and then we can ask those two questions.
Sure.
Is that Okay.
Dave Holtmeyer. So regarding the name change, does anyone have any thought as to whether Global Platform may do their own revision at some point in the future? And by having an IETF 2.0 and a Global Platform 2.0, there would be confusion, right? I think that should be part of the consideration for the name.
Yeah, if we call it 2.0, they can't then go ahead years later and then call it. There's also 2.0.
Well, I mean, they could, but then it's going to be.
It would be silly.
Okay, I would just ask, do we know whether Global Platform wants to use an IETF protocol that comes out of this working group? Do we know whether Global Platform wants to use the result of this protocol that this working group provides? Do we know?
We don't know that.
I don't know, they have not expressed that intention.
When you ask your second question, I won't know because it depends on the answer to that question. But those are good questions.
For the name change, you mean?
Yeah, just quick to the next question. I just look at the document. It literally says it's not final. It's a version 0.21. It's a public review. Okay, it's a static public review, not final. It didn't say standards.
Yeah. So
I hum in the mic, so it's okay. Stay here.
We will have to have the decibel meter here normalized. Okay, so I'm going to ask the first one, which is break compatibility, unless you care in the ordering. No. Okay, so the first question, and please hum, is the group willing to break backward compatibility with the current Global Platform OTRP specification? If you're willing to do that, please hum. Okay. If you're not willing to, please hum. Oh, pretty decisive. Okay. So we'll confirm that on the list.
Do you want to say the results for the remote participant?
Oh, good question. Okay, so for those who are remotely, can you just annotate on the Jabber if...
No, I mean, you want to tell them what the result was?
Oh, yeah, sorry. Okay, so for those in the Jabber scribe, there was pretty much unanimous consensus in the room that we are okay and willing to break compatibility with the current OTRP specification and Global Platform.
The front half of the room was pretty unanimous. The back half of the room was pretty silent. Yes, your summary is accurate.
Okay, so now for the second question. Is the group desire to change the name from OTRP to something else? And we can propose something, but let's ask that question first. So does the group want to change our protocol name to something other than OTRP? If you do, please hum. Okay, if you do not, please hum. Okay, so in the front of the room, it was slightly stronger for the no. How about on the back?
Same, I heard the same. Slightly stronger.
Slightly stronger for the second. Okay, so that is an interesting dilemma. Okay, so.
Given that, do we want to ask the third question for those who are humming for the no, or even for those who have lived with the no, new version number? Do you want to ask that question?
Yeah.
Actually, I think there's lots of people who don't care, but it means that they say that yes, we could vote yes.
Oh, do you want me to do a don't care hum?
Yeah.
Okay.
So actually, another process that we could use that's actually suggested by Pete's on consensus and humming in the IETF RFC is that if the chairs think that there's a lean towards one, we could say, are there any objections to going with not changing the name?
Okay, so let's do that so that we can make progress. Okay, so are there any objections for us to retain the OTRP name? Please hum. I think there might have been one or two, but not enough. Yeah.
can ask if they want to come to the mic and say something.
Yeah. If you have objections-
For objection, you have the option of coming to the mic to explain that. If you don't want to, that's okay too, but if you want to, now you can.
Dave Multimeyer, I did. And it was for the same reason I came up to the mic before. I think if we do a version 2, it could potentially create future confusion. I think changing the name would be a clean way to just ensure that we don't have any future confusion around.
Okay, well, I was going to go for a path forward, but I'd like to hear, because if we do retain the name, I do think we're going to have to formalize a liaison before we go that path. And so the liaison is there to help us communicate that to the global platform to get their opinion. Because
But there's a lot of ifs
but
in that.
no, because Dave brings up a valid point, which is, right, if they go and RAV their own OTRP, then there will be incompatibilities and confusion when implementers and users of OTRP, and they look at both OTRP v2, then is it IETF or not?
Yeah, I mean,
No, we should have the
I
discussion.
think we should answer some of these questions
Right.
before.
So Rich, hopefully you're taking the notes, because both Dave and I have stopped looking at the Etherpad.
Dave Wheeler. So I think that as someone who is outside of this working group, and in a year or two down the road, and seeing global platform OTRP and an RFC that's OTRP, it's going to be extremely confusing to understand what is the relationship. Is there any interoperability? And as far as creating a liaison to global platform, I think that that's useful, but in the interactions that we've had on the mailing list with a few participants from global platform, they've been unwilling to open up to any changes. And so even if we're willing to compromise some, there didn't seem to be at that time any willingness to compromise. So we can't guarantee that's going to be the case. If we have a strong preference to maintain OTRP, we can explore the liaison. But I think if we go in that direction, we should ensure that we have some point where we say, well, the liaison isn't working and we have to find another path.
And that's a fair point. Thank you.
Dave Taylor. So a couple considerations, and maybe these argue for our OTRP v2 pointer. I'm not sure. I have yet to see any OTRP specification that hasn't been in an internet draft format. If Global Platform did one, it would post-date the internet draft format. The internet draft format has a little blurb at the top that says it was contributed to the IETF for derivative rights. That means IETF owns the name. If there's a name change, maybe that should be on the global platform side. Unless I'm mistaken about my facts, right? My belief is the first version of it was an internet draft that had the normal text that's the boilerplate, and the internet draft that says that basically grants derivative rights to the IETF. That's an argument to not change the name, which was slightly more than half of the hums or whatever. It says if there's a name change, that's global platform's problem. We own the rights to it. It's a valid reason to say for back to we might change the version or whatever, but if there's a name change, the reason that I think I hummed part of the time and listened for part of the time for no was that I think that there is some visibility in terms of branding outside of global platform. And the change in the name causes confusion in the outside global platform components that already think of OTRP as being the thing that the IETF is going to do, right? And so trying to minimize confusion outside of global platform was why I personally hummed a little bit for no, is my answer to Dave's question. But the main point that I want to bring up was the ownership of the name. My belief is IETF owns the name from the process perspective. But I'm fully conservative.
Adam Whitaker, AX Enterprise. I just want to say I'm from the outside. This is the first time I'm hearing this, and I'm agreeing with both your comments and yours. It's going to be confusing. And I'm already confused. I'm sitting at the back and I'm already confused of what's going on. So I have to dig deeper. But just from a perspective of somebody who's trying to implement something, a TEE, and they walk up and they just Google search and this comes up, it's already making me want to walk out the door a little bit because I just don't get it. I'll go look for somebody who has a clear understanding. That's my comment on it.
Thank you. I'm kind of smiling because you agree with the person who wants to change the name and the arguments for people who don't want to change the name. No, I fully agree. I fully agree.
I see both sides of the argument. There are good points on both sides, and I'm not sure what one is the best one because it's not really my decision, but it's also, I don't have the experience to make the decision. So, but I see why this is a contention, but from the outside world, it's going to cause a massive rift possibly.
Dave Wheeler. So to your comment, Dave, I don't disagree with you at all. My position is, do we really want to enter into a fight over possession of the name, or do we want to ensure that the community and the ecosystem has a clear path forward and an understanding of the protocols that are out there?
So it's maybe not a decision we can easily make right now. So we maybe need to do a little bit more homework.
Well, and so Ming, you can speak your piece and we'll cut the line there. And
yeah, great guys. I thought the confusion is the one thing also concerned me. I can live with both, but for the options, but if I agree with Dave, if we can win that one, that we should retain it. As an intention, when we submit a draft to the IETF, as several even original sponsors by companies, the intention come to IETF, right? That was the interim want to go platform. So we should, well, hope, right, we retain the rights of name here. But on the other hand, in reality, OTIP protocol in global platform, with, for example, terminology, OTIP agent, that was in RE. So now in terminology here with a TEEP agent, change the name. TEEP agent in TE, not RE. So there will be some even terminology confusion. So I try to avoid this. Even retain name of protocol, but I think terminology, so we try to avoid that. I just skip that.
Okay.
okay, so for both decisions, we need to confirm those on the email anyway. But for the second one, I'm not going to post it as a confirmation, but more as a, we need to continue the discussion. The third point that I had, Hannes, which we can defer to the second hour because I want to give you more time and you only have 5 minutes left, which was what to do with the two drafts, to merge them, replace them, or I didn't know if you had. So that was another discussion.
Good question. So I was hoping to get a sense from this room whether this write-up is the right direction. It's not complete. It's a first version, and
well, that's why.
And this is sort of the overview, and I have some further slides in the deck explaining the details of each of the messages. But if you guys then think, after I go through this, that this is sort of the right way to go, then ideally a future version of this document would replace the other one. We wouldn't go parallel tracks. That would make no sense. And of course okay, maybe I go through this real quick and explain you some of the challenges I ran into. Some of them are William.
You're fine.
Okay, so one thing that I did, it's sort of like a little bit in line with some other activities in the IETF in SUD and in RATS and so on. Some people use CDDL for describing these payloads, these protocol messages, and so I tried to do that too. Which the whole point is that the description is supposed to be serialization agnostic. I tried to do that. Didn't quite succeed to make it really work across CBOR and JSON, but I'm hoping maybe during this week I get some feedback on how this actually works, because currently, if you look at it, it has the constructs for the CBOR COSI sort of or the COSI constructs in there, but I couldn't figure out how to get the corresponding Jose constructs. So maybe a limitation on my side rather than a limitation of CDDL. With the removal of the security domain management from the base specification, of course, the security domain management could still be added later as an extension if someone desires to do so. We're down to 6 messages, which are the trusted app install, the trusted app delete. The install is also an update, the success and the error message, and then the initial messages, the query request and the query response. The DA software is now described as in form of a suit manifest, and the same is actually true for the personalization data. We talked about this aspect yesterday in the context of the data dam, and that we need to find out from an architecture level on how we actually do this, and whether we really need the concept of a data dam or whether that can be merged together with the generic dam. But from a protocol point of view, it has no implications, but having a few examples there would definitely help, I believe. The personalization data as well as the software can be signed and or encrypted. And the manifest also has a way to identify the trusted applications, and this is how it's done. I also tried to come up with a sort of very much like the OTRP specification did initially, to have a sort of a common header, a common message concept, which is of a type, which indicates what the type of the message is. I have a token, and the token is actually a sort of a combination of, no, there's a token ensures the request and response matching. Is that true? No, I made a mistake on the last point. The TIT and the RIT, which was in OTRP, I couldn't figure out which one was used for what. It's actually, I think it should be combined into one, which is the token, one structure. So it may also be just me that I couldn't figure it out, but yeah. And then there's a message style, which is, there's an outer wrapper. This is the security wrapper that comes along with it, which is yeah, that's what COSI and Jose provides. There's support for extensions, because anticipating that some people will extend the mechanism. This is in there as well, specifically since we talked about this aspect of the security domains, and the provisioning of keys to the DE. As we discuss later, for attestation, we make use of EAT, which require these nonce to be included in the request, which is then used to guarantee freshness of the attestation response that comes back from the device. And I will fix the last line here. So that's sort of from a design point of view on how I did it. Here's how it then this looks like. So it's quite conceptually quite simple. So here's this wrapper, so it can be signed, marked, and then this is for the message itself, because initial message is the request is digitally signed, the response is digitally signed, but then subsequent message may make use of symmetric key cryptography. For example, if you need the keys to encrypt something. And then there are these type of messages, and the wrapper is outside, obviously. Yeah. And then this is how this query request looks like. So there's, as I mentioned, this common pattern, this type. This is the message type. Then there's this token for the request response matching. And then there's the couple of items. This is sort of the request with a couple of data type, this items, which indicates what you're actually requesting the device to return. Attestation information, other information. There are a few items I listed here. So attestation information, or do you want to get a list of the trusted applications installed? Because one can imagine not with every request you really want to get all the data again and again and again. And then this is sort of for cipher suite negotiation or indication, because subsequently the device may also provide a response back with, for example, by using the symmetric key algorithms, and obviously have to indicate that somewhere what the server actually supports. There's the nonce that I mentioned beforehand, which is optional, which is then used for the attestation mechanism, and also the version, sort of the version indication. That was also in the first version of, or the earlier version of OTRP. And then there's the OCSP data, also optional if it's needed. And then a response. I'm not going through all the messages here, just give you a glance. So this is then the response back. There's a type token, of course. The type is the response message. The token is corresponds to what was previously sent in a request. There's a cipher suite selected out of the available ones. If there's more than one version, then which one is selected? And here's the EAT, the token, the DA list, and potentially extensions that are being used and supported by the device. Skipping over the success, error message, and so on. Going straight to the open issues. I mentioned already that this issue of getting the harmonized description so that we don't have to have different versions for CBOR and JSON. In the discussions also yesterday, we had the debate of whether we need additional fields in the outermost part, so to actually allow routing of the messages to the right place as they travel from the DE, from the agent, all the way to the DAM. They need to be routed through the broker and vice versa. So if there are multiple DAMs and potentially multiple DEs on a single device, we may need some additional fields. That needs to be investigated. That wasn't there in the first version either. We have to provide a little bit of text on how the OCSP data is actually encapsulated, on whether we are just reusing, for example, the OCSP stapling from the TLS specification or something else. And also a more procedural issue on the algorithm recommendation, since we are now covering a wider field of use cases than before. Does it make sense to have the algorithm recommendations in the specification itself? And does it make sense to use it for different profiles, different recommendations? Because a smartphone tablet has different or will use different algorithms than, let's say, a low-end IoT device. Yeah, and the mapping, so the previous version of the specification described or went into great detail of mapping or explaining how these messages actually map to the JSON Jose encoding. And I think we need to add, even if we use CDDL, we still have to provide some of that information and put that back in. It may need to look a little different, but yeah, I'm looking to Ming and David for help on this issue. And examples obviously would be very helpful. We had some of the examples in the previous version. And of course, those need to be updated, which we would have to write code for to actually have these examples presented in a meaningful way. But we didn't start the coding of this version yet because obviously because of all the design decisions are still in flux.
Meanwhile, it's good starting. We try to collaborate to support the CBOR different serialization. Also, this actually change. As we will expand to a few more follow-up work. For example, one of those is now say what means a TA, how to represent TA, right? In response, it's more than like a TA ID, right? We will define format what's a represent TA information, and some will go to the attestation. So attestation return say what TE you're running on, right? The information about TE itself, the running environment, what TE version. Then cover TA, say what TA ID, what TA version, name, and other information. So in prior spec, we try to specify those in one self-contained document. So now we may consider So TA information, some, so it's belong to this OTRP spec. Some, so we collaborate that what EAT will contain, right? The information goes there. And what T attestation information need to go there, and we will define those. So that's a further detail we will continue to expand. Comment on the ID. Now we convert the TID and RID into nonce value. The intention of our original two values were TID means transaction ID, RID means request ID.
Yeah.
We use two as you may have a sequence of actions, sequence of requests. And the first one is a query request, right? Query request, query device status, then followed by install TA or update TA action, right? If TA already exists, I will update TA. If TA doesn't exist, it's install TA. So where they may use the same TID, transaction ID means but issue request always has only unique ID. So I can do audit, whatever, I have a unique ID to track, right? That's a request ID. But transaction extra, say, if I sequence of things, I have another ID, I can correlate them. That's more for practical implementation guidance there.
Yeah,
that was the intention.
I wasn't quite sure how I could use it because if I do a request to get do a query request and get a response back, what prevents me to do another request to then say install app? Why do I need to have a transaction concept?
Yeah, it's a normative, as we talk about normative. That transaction ID is a normative. It's more a kind of basic practice. So start with one query status, most probably followed by just another install TA. But I can always start a new query device status, right? Device state, because the last request may have been lost, right? Respond and come back. So this changes. But if it comes to multiple, then I can correlate them to provide additional information. So there was not enforcing identifier.
I couldn't see what functionality is missing if I don't use this.
Yeah. So, in the interest of time, I think
this is a smaller issue.
Yeah. No, and
yeah, right. We can. Yeah. The details are obviously up for discussion.
Okay. So, was that your last slide?
Yeah. So this is all I had. Yeah.
Okay. So, how many in the room have read the draft?
She was asking whether you read the draft.
Have you read the draft? 5. You think that's enough? Yeah. Well, you better have. You wrote it.
No, I wrote. I didn't read it. I was in write-only mode.
What do you think? Does that enough to do a call for adoption? I think we're going to.
If it's only 5 people that's going to read it, yes.
Yeah. Well, I.
The notes have it.
5.
Plus 5 plus 100.
Because part of this discussion is that I wanted to extend is, would the group consider this as a potential replacement to the current adopted OTRP draft? Yeah. So my co-chair is recommending that I could ask that question. So I'm trying to think of how to phrase it. Okay.
We've already asked about, is breaking backwards compatibility
Which we said
okay?
yes,
Okay.
right.
And so we said, given that Hannes is proposing a number of ways that break backwards compatibility, and the working group has consensus to break backwards compatibility,
Right.
is this a good start for breaking backwards compatibility?
Well, and I was gonna, but that's a different question. I'm just going to the tactical. So let me go to the tactical. The question is the group willing to adopt and replace the current adopted OTRP draft with this one? Does everybody understand the question?
Yes, no, and no, no.
Okay, so are you in agreement that we should replace this draft? Well, quick question. Yeah.
But I haven't read it. How can I answer your question?
That's the no.
No, that's the no. You can say yes, no, and don't care. So I'm asking the yes. Oh, don't, okay.
I want to say yes, but I haven't read it.
But
So how can I?
Yeah.
No, okay, so as a group, we have agreed that we're going to break compatibility. So he has proposed a new draft, and he's just walked through the description of how
Yeah.
and align with some of the work that's happening in the IETF. Okay.
Yeah. We have to confirm it on the list. Yeah.
I mean, we have to confirm all of this and take it to the list anyway. Right. So trying to get a sense of the room. So again, the question being posed is, are you in agreement that we should replace the current OTRP draft with what's currently called the OTRP V2 proposed draft? Please hum if you agree with that. Okay. If you don't agree, please hum. I heard us. Okay. And what about we don't know enough to make a decision? Please hum. That was a little stronger than the no.
And from over here, it looked like 1 was loudest, 3 was second, and 2 was third. They were both strong for them, but it was 1, 3, 2 in that order. Is that what you heard back there? Okay. So, okay. Yes, don't know, and no in that order, but there were hopes for all 3.
Okay. I'm.
Thank you. Yep. Okay, so we'll continue this on the list. So Hannes, until we get more clarity, we'll do the adoption once. Right. Okay, Soren. Oh, you don't know how to do that. Yeah. Okay. So 1, 2.
So how do I move it?
3. And then you have to sit. Sit.
No, but how do I move it?
Oh.
This is moving?
Yes.
Okay.
You got it?
Okay, good.
Yep. Yeah.
Okay, I want to discuss some use cases of using IoT for DDoS, and I want to present the use cases and see how do we go about it. Is it part of TEEP or not? So, as you know, if you don't, there are some reference in the draft. There is increased number of attacks of DDoS lately, especially growing with the fact that the number of IoT devices increase like 50x a year. So there are, if there's no protection, there could be a very dangerous thing to produce DDoS. There are 3 ways to connect with IoT devices to outside the TA. The problem is the devices like that don't have any communication outside are less useful for attacks, but the ones that are entitled to send transmit messages outside are more common. So they could be connected directly to the TAM. They could be connected via TEEP broker, or can be connected using T and multiple TAMs. So those are the 3 ways that they're connected that are potential being exploited by DDoS. Now, question is, should TEEP prevent such attacks? Is TEEP in the TEEP charter? I tried to put it in there, but it seems that it didn't make it, in a sense that there are IoT use cases, but not those one related to DOS. So now the types of attacks, I give some examples. There could be others, but those are the ones that were encountered during the latest 2019 attacks. One way, which is the most prominent, is to generate random traffic packets instead of data sent to legitimate data sent to operator or cloud, mostly cloud. The second way is reflect or amplify the network traffic. existent with legitimate traffic, which is also problematic. Using a man in the middle to insert malware generating traffic is less popular in the attacks that are observed. Use legitimate traffic at much higher volume is one of the most used in the last year or so, 2018 actually. And it can be triggered by a signal from operator or during upgrade or by time. So those are what I could synthesize from the papers that I read in this domain. So I put together 3 use cases, generic, not necessarily specific, but you'll see that they are used in different types of IoT devices. So first of all, there are 2 assumptions that make these devices potential targets and generators. Device allows software upgrades, which could in principle be unprotected and have inserted malware. A device transmitted that back to a service provider or public cloud. If we don't, it's less dangerous, but we know that that's the case. Now, the attack opportunities can be externally triggered to transmit random packets or amplify data to SP, and can be internally triggered by time. Those are, again, I'm scanning what was published. The second case, our device is connected to a gateway. Assumption for this use case, the device receives software updates secured via the edge server, and device is transmitting data outside the service provider or public cloud. So attack opportunities in this case can be internally triggered by time to transmit packets like before, can be triggered to transmit amplified legitimate traffic. So there's the one that could happen because there is, the edge doesn't necessarily know how much data should be sent back to the cloud. And the third use case, which is, in my opinion, closer to be useful for TEEP, to take care of them, is the smart IoT devices with rich OS, which is if you look at the document in the architecture document, that's exactly what it is. So assumption for this is the device allows software upgrades again. Device is transmitting data to the service provider or public cloud, and attack opportunities triggered to transmit random packets and can be internally triggered by time, which there's no mechanism outside that will detect and prevent. So just to give you some examples that are real, I mean, there were attacks, use cases like this. One of the first category is the IoT sensors and meters, health monitors, weather monitors, traffic controllers, public cameras. Public cameras in mod especially were used for this type of attacks. And there is a paper in the draft, you can take a look. The second use case is there is a home security and management system that actually collect all the information for IoT devices in the home, and then it communicate to the external to the cloud mostly. And such examples are smart building systems, smart cities, which are pretty popular, and smart clouds, hospital servers also. And the third use case, which is probably more easier to protect against, I guess, if we decide to do so, is the example of smart cars, smart air quality sensors, building security system. So this can be exploited less than other because first of all, their number is not so large. The attackers generally try to use large population of millions and billions of devices to make it more painful. And so there are some new use cases like small appliances with no OS, IoT devices not connected. I'm thinking things like this. So, there is a large population that could be used. So that's the use cases that I looked and I studied. And if you look in the draft, you'll see some references. I also wrote Python code to test if TEEP device will be able to prevent or stop or minimize, mitigate something. And unfortunately, I came to test it at a hackathon, but there was no TEEP on the other side. So the next time I will try to do, because the point is that it could be that this is not the place. I understand this, but I just want to open your eyes that this is a dangerous thing. It's very damaging and can, you know, actually all of you could be exposed if you don't, if you weren't. I was twice inside Dell, so, you know, it's real, so it's painful. So that's all. The question for me was, do you think that should we make it a working group draft or not? I continue to keep it alive, at least until we have the hackathon in Singapore and decide if we want to exclude it. And my point was that I tried to add these use cases, that's why I wrote this draft, to the architecture document with no, I mean, it was not accepted. So I just wanted to show what it is.
Yeah. So there's 1 minute left because we need to move on the agenda. So make it quick.
Dave Wheeler, quick clarifying question. So in your diagrams, you show a malware
I'm cutting it off
agent
at
going
me.
into the TEE.
Sorry.
Are you assuming that that's legitimately signed
Yeah.
code to get into the TEE?
Yeah.
So that means the developer who was authorized did something incorrect or
Yeah.
purposely malicious?
Could be. So, and open a door, a port that shouldn't be open, for example. I give an example, a stupid example, but yeah. Yeah. That's what, as I said, it's not real man in the middle because the intention is just to trigger or something less viral, but much more dangerous if it's enabled. So.
Okay, so let me ask a quick question. How many people have actually read the draft? Oh, quite a few. Okay. Four.
There's quite
Okay.
a few.
Yeah. So we're out of time. So I think what we should do is continue the discussion on the mail list because I think you're raising some good issues that at least need to be placed in the security considerations in both the architecture and
That's
in
why
the,
I wrote the draft because I was trying to make some points and I also was out of time. So.
Yeah, no, and those are very fair points. So one of the things that you can do is open them up as issues to ensure that the authors don't lose sight of it as they need to be included in both the architecture
Well, I
and
was in
protocol.
touch with Hannes, but you know, I want
Yeah.
more than just Hannes.
Not people,
busy
the
or
GitHub
something.
issues. Yeah.
So,
Yeah.
okay, thank you.
So thank you. Okay, so with that, are you presenting?
I think, yeah, I'm going to start up the moderation of the rest.
Okay. And I said 3, right? 1, 2, I don't know why.
All right. So I'm now going to lead a little bit of a discussion about TEEP and RATS alignment, right? Last IETF, we got consensus and then confirmed on the list that, yes, we did want to align with RATS rather than doing something that would sort of duplicate some of the attestation stuff, okay? But that was a principle. And exactly how you do that, there's a lot of flexibility in, right? Given that the OTRP protocol may still be evolving and RATS is still pretty early in the architecture discussion, and there's a bunch of different variations. And so there's a bunch of different ways that RATS and TEEP could work together. And so I'm just going to present a bunch of different options. I don't have a specific opinion, right? But it says here's the different options that the working groups between RATS and TEEP could choose. We could choose one of these or choose multiple or whatever, but there's many different ways to put RATS and TEEP together. And so that's what we're going to talk about here. Okay. For those of you that have not been to RATS, okay, the roles that are relevant here, there's an attester, okay, somebody that's trying to prove or assert correctness. There's a relying party, which is going to make some decision at the end of the day as to whether the attester is allowed to do something that the relying party has. And then there's a verifier. That's the thing that actually can make an authorization decision, or can make some authorization decision, which may or may not be exactly what the relying party is using. Okay, so there's one model that I would liken to the way that humans use passports. Okay, when I get my passport, I go and apply to, say, the U.S. I get a U.S. passport, and then I can present that to people, like when I'm going to board the plane or check in. I present that to the security people. They look at that passport and says, that looks good. It's signed by the U.S. government. That's close enough for me because I grant that this is a valid passport, right? I can detect that this is a valid ticket, and so I let you through, right? So the human workflow is equivalent to this one, right? We present a bunch of evidence to some authority, call the verifier. What you get back is some attestation result that you can then present to various relying parties, right? So in the human example, the attestation result is the physical passport that you carry around, right? So that's what I will call the passport model. That's my term. I'm trying to give analogies to non-rats people as to human workflows that we use today. Okay. A second example model, which other people talk about and maybe other proprietary systems use, I will call the background check model, right? So I fill out an application to do something and I fill in all of my data or whatever, and the relying party, maybe the place I'm trying to apply for a credit card or whatever it is, in the background, they go off to some verifier and they do a background check on me. They verify that all the claims that I made are correct or not correct, and they maybe get some other data about my background, and then they make a decision like whether they're going to grant me that credit card. Okay, so I call this the background check model. Okay, and so here, the evidence that the attester supplies to the relying party then goes off to a verifier, gets the actual results, and that's what they act on. Okay, and so the verifier here is comparing evidence against some policy, reference values. Is this evidence good based on my processes? And they get back an attestation result, and in both cases, the attestation result is what the relying party then uses to actually do some action. Okay, so the relying party could have some additional policy that's based on what comes back in the attestation result, like whether it's allowed to do operation A versus B. Yes, I know it's Dave, I know who he is and who he works for and how old he is and so on, but whether he wants to do operation A or B is inside the relying party, right? So there's two levels of authorization steps. Okay, so that's kind of rats in one slide, and all the other discussion is about exactly what is this EAT thing, is that evidence or attestation result or both, okay? Like if you look in the EAT document, it claims it could be either one, right? You can use an EAT for either of those. And exactly which model is it and how do they relate, and all those are possibilities within rats right now. Okay. Or at least within the rats working group, different people have both models and different variations. Okay, so that's rats in one slide. Okay. All right. And by the way, the verifier and one of these roles could be combined, such as verifier and relying party could be in exactly the same device. And so this could be a simple API call internal to the device, not a protocol, right? Okay. All right. In OTRP, we have this, where we have what I will call the attester, which is the TEE. You have a relying party, which is the TAM. And you have some information that in OTRP v1 was called the device state information. And that's the part that we says that looks a lot like the information that goes into the evidence or the attestation request or whatever term that you want to use. Okay, so we said that's the part. The device state information is what overlaps with what rats was doing. Okay, this piece here called device state information. Now, of course, OTRP also takes care of install TA, updating TAs, deleting TAs, and so on, which I think of as being remediation steps. If I am not in compliance with the policy that's out there, I can do something about that, right? That is in scope for TEEP. That's not in scope for rats, right? TEEP says, how do I remediate and get you into the good state? You're supposed to have this new version of the TA. We can do that, okay? And so between this diagram and the previous diagram, there's 3 or 4 ways that we could possibly combine them, okay? And I'm not going to recommend this is a survey, right, to generate discussions, to say, because different people may have different opinions as to which one they have in mind. And so maybe we want more to accommodate one or more than one. Okay, so let me walk through these. Here's an option number 1. Okay, this one is based on what we call the passport model. Okay, remember the passport model looked like this. A tester goes to a verifier, gets back a result, and then passes that to a relying party. Okay, here you can see OTRP is the bottom line, and some other protocol that's not OTRP is back here. So in here, what happens in this particular model, it's saying what we would call the device state information in the existing protocol would carry an attestation result, okay, in the RATS terminology, okay? And then the relying party then uses that to compare against some reference values or whatever to make some decision based on what this entity is allowed to do according to his attestation result, okay? So that's the passport model option. So here, what happens is the verifier and the relying party are just 2 different services that are both used by the same attester, right? I do attestation this way, and then when I'm not in compliance, I go off this way and I kick off the remediation flow. Okay, that's option 1. Option 2, okay, is where it's closer to the background check model. Okay, if I take that diagram and overlay it, so you can see OTRP is again the protocol between the attester and the relying party. Okay, and you can see the relying party does the background check and goes off to some type of service that's the verifier, and the verifier compares against reference values. And so here, what goes in the device state information is evidence, meaning the thing that goes to the verifier, not the thing that comes back. Okay, so in here, the attester passes information to the relying party in, let's say, his get device state response. Right, on the back end, right, it goes off to the verifier and says, is this the current correct state? Oh no, this is not the current version. You are not in compliance. Attestation result is a failure, for example. Okay, great, I'm going to kick off the flow. So that's one example of a way to compose these. Okay, evidence goes in the device state information. Okay. Okay. I mentioned before that these two could be combined in our RATS model, where it's the two different entities within the same device. That could still be the case here, right? Same diagram as the previous one. OTRP is here. This is all inside a combined TAM that has the policy itself, right? And previously in TEEP discussions, we kind of thought about it this way, where there's a protocol that carries device state information and the TAM just makes a decision. That kind of fits into this option number 3, the way that the architecture document is currently phrased, okay? But when we talk about RATs, are we talking about evidence or attestation result and device state information, or allowing either of them because different people have different use cases? That's up to us to talk about and decide. Okay, so that's option number 3. Okay, now I want to have another variation where I'm going to take exactly the same picture right here. I'm going to rotate the attester here down into the bottom so it fits on the next slide. Okay, so keep in mind that verifier, relying party, attester. So the attester gets to the verifier via the TAM, right? Because it's the okay, so basically the previous one, right? Potentially 3 roles. I'm going to take the attester and rotate it. Okay, so here's the previous one, which is these 3 here, right? So OTRP was the one that was over here, right? So here's those 3. But now the attester wants to speak some other protocol that has nothing to do with OTRP. Okay, he's going to speak some protocol like HTTP or CoAP or whatever to actually do some action inside of a TA. Okay. And so in doing so, that other protocol, that other relying party that's not the TAM relying party, some other relying party wants to have an attestation result in this example. Okay? In order to get that attestation result, the attester needs to go in the passport model, the attester needs to go off to a verifier. This is saying I can compose 2 of the previous ones to get this picture that says, okay, well, one way to use the verifier from the attester is to go off and get a passport, for example, this way here, and pass it across to the other protocol there. This does not work in the current protocols. This is not in scope for the current ones. The difference is today, OTRP does not have a way to pass back an attestation result. It can install a TA and it can install code, but it can't install a token or an attestation result. Okay, there's nothing to do that. So if anybody cared about this, then one would need to extend OTRP to do this, okay? Which is why it's another option in the list of survey, right? The other ones could be done without protocol extensions per se. This one would require, say, in addition even to OTRP v2 to carry a token, okay? If anybody actually wanted to do this type of model right here, okay? That's the list of the possible models, right? All of these are valid or correct or whatever according to different interpretations and use cases, okay? All right. The RATS working group has had lots of discussions about freshness. So this is my summary of freshness and what that means. Okay, and so Hannes talked about the role of the nonce, and so I'm just going to elaborate on that briefly here. The information supplied to the verifier, you want that to be recent and not like replayed from 3 months ago. How do you verify that? Okay, so that is done in the RATS architecture by having a nonce be generated such that the information supplied to the verifier has to include that nonce and be signed. Okay, and so OTRP v1 has, for example, it has a request ID and a transaction ID inside the get state request and in the signed get state response. And so in that sense, the RID kind of assures freshness because the get device state response itself is signed and includes the RID, which is kind of like a nonce. Okay, but it's not inside the encrypted part of the DSI part of the response. It's only in the signed part of the response, right? Because it has an encrypted piece inside of a signed piece. And so the nonce is signed, but the nonce is not encrypted in OTRP v1. In OTRP v2, what Hannes presented is there's a nonce in the query request, and it's inside the EAT in the query response, which could be encrypted. Okay, but otherwise, both of these do have a nonce. In one case, it's only signed. In their case, it's signed and encrypted. Okay.
So my point is related to the previous discussion, but just in the case, I want to explain my. So in my opinion, there are in OTP1 there are things that are important for the use case that we're talking, and they disappear in V2. That was my reason. So maybe because you simplified it and you, for example, the get device state response is not there, right? Because, or, yeah.
Yeah.
No, yeah.
What OTRP v1 called get device state response.
I read the documents and yeah, so that was my concern, that because of compatibility, you may lose some functionality. That was my understand. That's why I thought it's not.
No.
I thought that's why I thought it's
V1 and V2 are functionally equivalent. The only difference is in this respect, in freshness, is the nonce is encrypted in the response.
Yeah, on that respect, it's the same. It's at least not intentionally, I didn't lose functionality.
Right.
I lost some other functionality, but that was
not that
based on working group decision.
Yeah. Okay. For your information, to make sure you're not confused, just using the nonce, just the notion of a nonce itself, does not guarantee that the information that you received is still valid at the time that you received it. Okay? It may have changed since it was sent, right? Or since you get around to processing it, right? There could be a race condition, right? And so for that, you need, if you wanted to solve that, then you need something that's more like channel binding, right? So for example, there's two things that might have changed, right? The policy might have changed since you sent the attestation request. And so, the policy might have changed by the time that you get back the attestation result. The policy and the verifier might have changed, okay? And so what we did in OTRP was we said there's a time window when we check it periodically, right? And so when you generate an attestation response or whatever, you make a decision, that's going to be good for a particular period of time, and policy might change in the meantime, but you'll eventually catch it at this bound. Okay, that's what we did in TEEP before. Okay, and secondly, the thing that could have happened is the device sent out some claims or state information. Okay, and that might have changed after the device sent it. Okay, and so here, this is where you need something like a channel binding that says, well, okay, you have a particular session that you're using to talk to the tab. Okay. If the device state changes and the session goes down and you have to have brought it up, so let's say you have to reboot to install something. A reboot would have forced the session to go down and then you'd start over. That's the class of things that you'd have to do that or something more cryptographically strong in order to care about this. Otherwise, you just admit that says, yep, by the time that I get the attestation result, it may already be out of date. Okay,
so
that's
just
okay.
the time check, you have 5 minutes left.
I only have one more slide. This is my last slide here.
Good.
Okay, the last slide, okay. In order to use the RATS work for TEEP purposes, okay, since RATS is attestation for arbitrary purposes, and we want to use attestation for a particular purpose, right? Like installing TAs, for example, okay? That means that the attestation result is going to carry a set of information, okay? But the RATS working group can carry out information for just about any purpose. So we have to define what is the specific types of information that needs to be in there that's relevant to our purpose. Okay. Turns out that the architecture document already has a statement that says we're going to do this. Okay. Hank is smiling because he was saying, yeah, TEEP should do this. Well, when Dave Wheeler made the update recently, he stuck in this particular text that has a shall, right? That says, okay, we shall do this. The registry shall be defining the OTRP protocol. So this is a requirement for the protocol spec that the architecture document currently makes as a shell that says we will do this, and you can see for example from, because this is just an individual submission. It's not the working group document yet. So this could become stronger in the future. But the point is this would be work for the TEEP working group. Okay, Hank.
Yeah, hi, this is Hank, as a robot enthusiast from RATS. I think there are a lot of interesting points here. So you have, from a presentation I see you have 2 places in the arrows where you can use a token.
Well, you could, yes.
Use a token. Not just talking about which of the options. So it's something that gets from the attester to the relying party to the verifier. That is the entity attestation token at its best, so to speak. I have to highlight every claim in there is optional. So what we will discuss in REDS tomorrow, I guess, at some point, is can a flavor, like we now need TEEP flavors for EAT. And that is a principle of the EAT draft itself. There shall be flavors for solutions. And one of the questions we will discuss is, can as the original EAT has no mandatory claims, can a flavor impose mandatory ones? Can it make, for example, the nonce mandatory? And I think in your case, there are probably a lot of mandatory ones and some optional ones. So that's the first thing. And I think that is working out quite well. That would match. Then you have the attestation result. REDS isn't quite there yet, but we have an understanding that the verifier sometimes wants to say more than yes or no. It wants to say yes because, first of all, firmware is not in my version. Also, you have to reboot every week, and you are 2 weeks uptime. That's also a no. So install firmware, reboot, and then come again and do the attestation. So attestation results can be bound to the actual claims and annotated, or they can be something else entirely because they're specific to a policy you're adhering to. So you have two sets of claim flavors you have to create in EAT, as these would be two drafts in TEEP. Which one is attestation from the attester claim set, mandatory and optional, and the verifier to the relying party claim set, which attestation result is completely new, and the TEEP working group will be the first source of that. This is my summary.
Okay, Robin Wilson, could you go for
I'm going to cut the line off at Ming because we're running out of time, and I need to respect. Dave Wheeler also has a presentation on attestation. So,
Robin, which slide?
I'll try and be brief. Just forward one slide, please.
That one.
Yeah, I like this because I think your analogy with passports and identity-related attributes is very useful. To my mind, I think you're going to always need a combined architecture, or an architecture that can combine the two approaches.
I mean both options.
You mean both options?
Both background check and passport model is what
right.
Okay.
And, my use case for that would be that from the attester flow through to the verifier, the passport flow, you get assurance of the device's identity. But what you can't get from that is is to form a judgment based on the device's behavior. And the device behavior is going to come from other sources. So I think option 3 here, or possibly if you go forward one more slide, this one, but where the relying party can actually go out to other sources and say, well, actually, is this device also behaving correctly? Well, I think that would be really useful.
Right. This slide is not another option. It's not option 4. It's just saying this is an example that combines 2 of the previous options into an overall use case, right?
Right. But the flow down at the bottom, the attestation result, going from the attester to the other relying party, struck me as less useful than one going from the relying party in the middle out to other sources of attestation.
Okay. Ed?
Ed Smith. The question I have is relating to the query request response exchange and whether or not the intention was that the key signing the query request is the same as the key that's signing the nonce in the query response. In other words, the signer of the attestation information, is it assumed that it is the same key as the signer of the query response? There could be multiple keys.
I don't know if I understand the question, but I suspect that Dave Wheeler's presentation, I think, will answer it. I don't know if Dave Wheeler agrees with that, but. Okay.
He's asking that, there's a query request and a query response, and they both have some cryptographic binding in there.
They're coming from different parties.
Right.
Right. So, but David, he's asking, are we using the same key? Could be a symmetric key.
The signer of the attestation information, which includes the nonce in the response, could be using a different key from the keys that's signing both the request and the response.
Okay, so let me allow David Wheeler to kind of address that in his presentation because we're out of time.
Yep. For those remote, what David Wheeler said is they're coming from different parties, so they can't use the same key. So I'm trying to stall time. You should be on your way up here, right? Because that was my last slide. You're up next.
So as I'm putting up his slides, I'm going to speak as both TEEP and RATS chair. I think this is an important discussion. To the gentleman's comments, I didn't quite catch your name. There's going to be a side discussion on Thursday, I think at 8:30 in the morning, on the use cases. Hey, come on, 8:30 in the morning, you can handle that. Come in at 9, how's that? So there's discussion there on the use cases. So it would be good, strongly recommended, that those get into the RATs. And then and I'm going to suggest, I'm presuming that RATs will have a virtual interim, that Dave, if you're available, you present those to the same slides. Okay, so with that, you've got, yes. If you can look it up, because, yeah. Okay, let's let Dave Wheeler speak, because you have 14 minutes, sorry.
So what I want to talk about is some of the analysis that I've been doing over the last couple of months on different ways of putting together the attestation mechanism. From our last meeting, one of the questions posed to me was, can we use the suits manifest to carry attestation, for example? And so the current draft of the architecture spec says, hey, the attester is going to be the TEE, the verifier is going to be the TAM. There are models, like Dave Thaler pointed out. I think one of the things I'd like to say is that a lot of times the TAM is making the policy decision, so they want to see the entire attestation token, but there are cases where the verifier needs someone else to verify a signature, verify that the public key hasn't been revoked, or things like that. So there are different structures and different reasons other than someone other than the verifier looking at the token. And we can talk about that probably in more detail at another time. But the open question really is around the claims, and how do we structure the claims, what's mandatory, what's not mandatory. So from my perspective, I think our claims need to be well structured. They have to be easy to parse. They have to be unambiguous. They need to be minimally self-contained. So we shouldn't be requiring significant outside information to interpret them. They need to be extensible, because I don't think we're going to get all of the right claims figured out here in the next several months, right? And there'll always be TEEs or other security policy decisions that a TAM might want to make that would require additional claims. And then we also need to support proprietary signatures and formats for the attestation, because current TEEs aren't going to change, right? They're still going to be out in the environment. So for TEEP to work on those existing implementations, we need to pull in some way to handle a proprietary attestation format. So the complexities as we start looking at this are, we've been talking a lot about SGX and ARM Trust Zone. We talked a little bit yesterday about the trusted firmware and having chain certificates. Those things are all things that we're talking about. We aren't talking about other types of virtual machines or platform-based TEEs where I may link other ASICs or hardware elements together to form my TEE in for example, a VM. And I think we had some presentation a little bit about, should we consider, cloud-based CSPs. But I think it's important for us to think about how complex some of these platform TEEs can be, and make sure that we can link together the right signatures from roots of trust. So what I looked at over the last couple of months was, can I use the suit manifest specifically to carry the attestation? And I liked that idea a lot, but I couldn't quite get it to work in a way that I liked, because even though it was self-contained and extensible, and I really liked the way CDDL allowed us to do that, it didn't end up being unambiguous, because the manifest structure required me to kind of redefine the usage of certain elements, and I didn't like that. The EAT token is well structured and self-contained. I think it's a good start for a dictionary of claims, and there's some recognition for a need for extensions. It wasn't really clear to me in the current draft how those extensions were managed. So I'm sure that in the ideas of the authors and others in RATS, they have an idea for how they're going to move forward with that. It wasn't clear in the current draft. So my perspective is, I think we need to merge these together. CDDL should be used, I think, to define the attestation token, and that's something that I'll push back to RATS, and I think it's something that we should coordinate with them closely. So that's sort of my proposal. We don't really have time to go through some of the details that I have. If you're interested in some of the work that I did here, I've got a proposed CDDL for an attestation token that we can put into the protocol, and clearly that's something I'd like to work more on with others from RATS as well as TEEP.
Dave Holtmeyer, I guess as a participant from a suit perspective, we haven't been developing the manifest to really be used for attestation.
I know.
So I find it kind of interesting that you're looking at it for that use case. This kind of goes beyond the scope of what we were trying to do in suit, and that leaves me really confused as to what it means to actually merge the two, because I mean, are you talking about using CDDL in this case? Are you trying to use the pattern that we're providing?
Some of the pattern and some of the reuses. In my discussion with Moran last time, he said, "Oh yeah, you could put an attestation token in here." So, and I hadn't ever looked at the details of the suit manifest before, and I was unfamiliar with CDDL. So that was the purpose of doing that.
Dave Taylor, another suit chair. So at the suit chair, meaning not the TEEP chair, right? You said verbally just now what I was going to say and expand on. On your previous slide, you had a couple different options there, and the third one would be to merge the EAT and the suit manifest. I'm going to argue against that. And what you just said is a much better way to phrase it. Is you could carry an EAT in a suit manifest the same way as you carry any other file or binary in a suit manifest, right? That is appropriate, and what we talked about at the TEEP interim when Brendan presented here, you could express just about anything in a suit manifest, right? It was originally designed as the primary use case for carrying firmware, right? But you could carry anything that could be expressed as a file or a blob, and an EAT is an example of something you could pass, right? And so in my presentation where I said, even in the composed one, if you needed to pass an attestation result in a TEEP message, you could do that by sticking it inside of a suit manifest, right? That's one way the working group could do that. And that's, I think, is your second option outside here, right? Is to use the EAT token for the claim language, right? And which you could carry inside the suit manifest in some cases if you needed to, such as in the install TA, if you needed to say, here's your attestation token. It's one of the different ways to encode it. On your last slide, I'm also confused about what you mean by the last one, merge CDDL with EAT token. I think that's what Dave got up to say, and yes, if you can elaborate on that one, that would be great.
So perhaps it was my misunderstanding in my conversations with Brendan on the manifest. In the private conversation I had with him, he he recommended that we reuse some of the data structures and things like that in the manifest, and that's primarily what I was trying to do. I found it easier to just restructure those. So the current EAT draft is not defined in CDDL, and I'd like to see that reflected. So that's something new, I think that we should do, and I think that the CDDL allows us to express extensions better.
As the RATS chair, I do believe there's been discussions in the RATS group, and so if you have the time, I encourage you to attend. We're meeting twice.
Okay.
And so raising that, and in fact, we're going to be talking about the different token formats and expressions, I believe, on the Thursday session.
Okay.
And then Lawrence will be going through the EAT on Wednesday, so you can express requirements there as well.
Great.
Ned Smith. So earlier was mentioned that the tokens in EAT are all optional essentially, and that TEEP is going to have some that are mandatory. So it seems as though there needs to be some sort of TEEP specific profile for what's included or not included. That seems like an appropriate point to talk about combining. I don't know what you mean by combining the manifests, but it seems as though there is some TEEP specific expression of a manifest.
Right. So something we'll have to do, and now I'm speaking as both the TEEP and the RATS chair. When we do the IANA registry for the different tokens, we'll have to consider, I'm thinking now we'll have to consider applicability and mandatory, so we'll have to work together on how we categorize the IANA registry for them. Right.
So one more point I think that hasn't come out in any of these presentations that I is partly in the architecture spec is that there's an aspect where a TAM is going to make a policy decision, and they're going to know ahead of time what specific claims they'd like to see from a TEE. And we need to think about ways for a TAM to communicate that information a priori before the attestation is created to avoid multiple flows. So if I'm a TAM and I want to see your secure boot measurements, I should have a way to express that to you in TEEP and say, hey, even though this is perhaps optional in the TEEP specification, for me to approve you, it's mandatory. And so how we do that in the protocol is something that I think is still open, and it crosses between both the protocol messages that we need to create and this whole one pass, two pass kind of thing, and the format of the attestation token.
The nonce is in that category right now, right?
Yeah.
Yes. Nonce, timestamp, other things like that, yeah.
So my comments is largely concur what Ned said and Nancy said. I treat RATS or EAT as a generic token format. We need a shared attestation format. What concrete claim should be, that should be owned by TEEP. TEEP will have their own claim registration. What it should be, and use that as standard format, right? So that's for that purpose. Then, but policy and claim registration should be in TEEP. Like policy for freshness that they mentioned, right? If there are that policy within that, just like OCCP data validation status, similar, right? How long should it be acceptable? So on.
Dave Waltermeyer. I'm probably not going to make it on Thursday, so I just wanted to make a quick suggestion. You might want to consider having a registry of sub-registries that would allow for different groups to have different sub-registries that they could then manage themselves as a way to sort of organize this, because I suspect that TEEP is like the first of many other groups that are going to want to do something in the attestation space.
Yeah, and I suspect we're going to continue this discussion. So, is that it?
That's it.
All right, thank you. So, we actually have 1 whole minute left, and we've made good progress. Blue sheets. If anybody hasn't signed, raise your hand, and we'll pass the blue sheet.
Where's the second blue sheet?
Yeah, it's back there.
Okay.
So quick question, Hannes?
Yeah, I had a chat with Dave yesterday evening, and we thought that it would be nice, or there was the idea to put together kind of tutorial on for the next IETF meeting, a hands-on tutorial for using sort of like these TE technologies with what we are doing. And so we were wondering on how many people would actually be interested in such a tutorial, assuming they attend the next IETF meeting. So maybe on a Friday before the hackathon starts, to do such a...
Or you could do it on the Sunday too, if people don't.
Yeah, Sunday is pretty packed already. But in general, like,
Yeah.
I don't know if people like that idea, but it would be.
I think that would be good.
Work, but if nobody shows up, we don't do that.
Well, at minimum, Hannes, I think it would be good moving forward, since I think that we had 2 new participants. If we had like 2 to 3 introductory slides that we could kick off the first session, right?
Yeah, well, this would be more like deeper dive with a hands-on.
Okay, so we're out of time, but I wanted to ask one quick question. And